Hello, everybody. There we go. So firstly, I should apologize. I have a slight cough today, so if I croak, choke, or otherwise lose my voice, this being an AWS talk, I have a hot standby over there, and my glamorous assistant, Matt. He hasn't seen the slides, but what can possibly go wrong? OK, so what I'd like to do today is give you sort of an overview of Trainline's cloud and DevOps journey over the last 12 to 18 months. And specifically, I want to touch on a number of different areas at a sort of high level, just to give you a flavor of what we've done, and then drill in specifically to our deployment automation and how we manage our infrastructure environments. So you probably know who Trainline are, but a quick bit of background. We do about £2 billion worth of ticket sales a year, 28 million visitors a month, and 70% of our traffic now for advanced tickets is via mobile. How many of you have got the app on your phone? Excellent. Great. The rest of you can download it while I'm talking. So we actually help our customers do about 100,000 smarter journeys every single day. Trainline as a company has been around for about 15 years, which is long enough to accumulate our fair share of technical debt and legacy systems. So let me start there. Let me take you back to June last year. We had a number of challenges. We had a monolithic web application or platform. And what this was a giant .NET mess with a massive Oracle database and lots of integration by database anti-patterns going on. That posed a number of challenges. We had one release of that platform every 6 weeks. So that was a classic rocket launch, lots of upfront planning, rollback testing. Everyone comes in at midnight, and we cut the site off from live. We had legacy tech. Oh, did we have legacy tech? We had Windows Server 2003, we had BizTalk, we even found some VB6. We also had legacy hardware, so we had some Citrix NetScalers, and we had some Oracle Exadatas. Some of you may not think those are legacy, but in terms of cloud migration, they're obviously not very helpful. We had one physical data center, which was a colo in Rotherham, and our DR solution would probably have taken a number of days to stand us back up. We had centralized ops, so a lot of our teams were centralized and functional in nature. So the developers did development, they passed it to the testers, passed it over the wall to the operations guys to actually run this stuff. And probably our biggest problem was environment snowflakes. So every environment was its own special little creation. And we reckoned that we were wasting about 30% of our developers' time just dealing with environment issues. Waiting for an environment to be built, which took 2 weeks, waiting for environments to be refreshed, trying to figure out what version of which application is deployed where. Why does it work over here? Why doesn't it work over there? Does that sound familiar? So that's where we were, not a great place. So we set ourselves a challenge, and the challenge was this: go faster. Which sounds very simple, but actually it required a fundamental rethinking of our culture, of our processes, and our technology. So this meant adopting a DevOps culture. It meant updating our tech stack, moving from Windows to Linux. It meant moving to continuous deployment. And it also meant, obviously, migrating to AWS. Now, one of the reasons we chose AWS, apart from the cost and the range of features they do, it was also because the rate at which they innovate. Hundreds of improvements every year. And we wanted to harness those and make those facilities available for our features to help our customers faster as well. So that was a major driver in us picking AWS over the competition. So where do you start when you've got a challenge like that? We started with the organization structure. So what we did is we moved from functional teams to small cross-functional teams, which we call clusters. And literally, we split out the teams. So our operations guy, we had an operation guy go into each of the dev teams. Our testers, we split out. Excuse me, and so on. So we ended up with these small, empowered, agile teams of no more than 10-ish, who were each responsible for a product as opposed to a project. So previously, it was all project-based, which made it very hard to get things like tech debt approved because there's no obvious business case. If you're product aligned, it's much easier to get those things done. So that was the first thing we did. We then looked at our application architecture, and we needed to move from our monolith through to microservices. Now, the way we did that was by assigning ownership to the teams. So if you, as a cluster, own a particular section of the code, you want to be able to build, test, and release that bit independently of everyone else. So surprise, surprise, you start getting versioned API contracts appearing, which helps naturally break up the monolith. And we've now broken it down to roughly 250, not strictly speaking microservices, but certainly smaller chunks of functionality. Then we looked at the cloud readiness and the cloud sort of checklist. So obviously, when you're looking at an AWS migration, there's lots of different ways to skin that cat. You can just lift and shift stuff and remediate it in place. You can raise the bar and get it in, or you can build cloud-native versions alongside and then flip over. And it can vary based on the applications as a mixture. What we did is we defined a checklist which defined the quality gates. What do you have to do to your application to have it be cloud ready for our target? So number one up there, always at Trainline, is security. Making sure that the application is, encryption at rest, TLS, various multi-level security things which you would expect an organization like us to have. Modernizing the tech stack. Making sure that it's able to be operated. So for example, centralized logging, instrumentation so that you can see what's going on when it's running in the cloud. Architecture, removing singletons, coping with disaster, high availability setups and all that. You'll know various products and more cloud-friendly licenses than others. And so those were the sort of 5 criteria, and there was a checklist under each of those, and that sort of acted as a to-do list and a sort of lightweight project plan. So we knew what state each of the services were in and when they were done. Excuse me. In terms of the actual migration approach, the first thing we did was look at the common infrastructure. So the CloudFormation scripts for the VPCs, for the security groups, the subnets, the network infrastructure to make it all work. We also defined the base set of standards that you need to avoid yourself going off in an undefined way. Instance tagging, naming, usage of S3, usage of IAM, the basic kind of stuff. Not heavy duty, just enough to get us going. We then tackled each of the services one at a time, moving it into the cloud based on its risk and based on how sensitive it was to latency. And we proceeded like that until we hit the point at which we had to tackle the big, bad database. So there were 10 very high-performance, very chatty services which we had to move alongside the database. So we did this as a proper outage, sort of like the old 6-weekly release. But we have enterprise support from Amazon, and they provide an infrastructure event service. So we got them in, so everyone was in at midnight, and we did lots of rollback testing, and we did the migration. We were then able to sort of sweep up the remaining services which weren't yet remediated or which couldn't move until the database was done. So that, at a high level, is how we went about the migration. In terms of the AWS services themselves, it's fair to say we have embraced the ecosystem. These are probably the top 10, not necessarily in any particular order. Just a couple which I want to highlight. First, auto-scaling. I don't think this gets enough love. We actually use auto-scaling groups for all of our application instances, regardless of whether we have any intent of dynamically scaling them or not. And the reason for that is that it makes it so much easier. It's a unit of management. And you can do things like scale-up patching. So you can launch a new version of your AMI. You can update the launch configuration of the auto-scaling group, double the size of the auto-scaling group. The new machines come up, use new AMI, and then you halve the size of the auto-scaling group, and lo and behold, it takes the old ones out. You're left with a full patch fleet with no downtime. Very effective, very easy way to do it, and a nice, easy thing to automate and script when you're patching a lot of servers. Another thing to highlight is Lambda. So we are doing Lambda. One of the things we're using Lambda for is our delay repay service. So we get about 250,000 events a day telling us that various trains have come in and out of various stations on time or not. And we can actually use that data, cross-reference it with the tickets we know our customers have bought, and automatically send them a notification and automatically refund them if they're eligible for a refund. So that's an example of a Lambda service which we're running in the background. We also use Lambda for various housekeeping and maintenance tasks within AWS. So for example, scheduling instances or scheduling environments, turning them on and off at a particular time, or keeping an eye on our security groups and notifying us and changing them back if someone has changed it in an unauthorized way. So Lambda's got a number of different uses, both on the app side and on the ops side. And last but not least, I want to highlight, as of today, I think, a new use of Kinesis that we're pushing out. We're now streaming millions of customer journey searches through Kinesis and offloading it through Kinesis Firehose into an S3 data lake. And we're using some quite powerful analytics to then help our customers make more informed and better searches. So that's just a start of what we're going to be doing in that space. That's a big push for us this year. Okay, a word about performance. This is what performance means to us. We made a change which made our website 0.3 of a second faster, and it made £8 million difference to the revenue in that year. So it's something which we take very, very seriously. And I'm pleased to say, actually, as part of migrating to AWS, our performance went up, even though we're using a lot of T2 instances and a lot of horizontal small machines. It works very, very well. Continuous improvement. One of the key lessons I think we learned is that if you have product-focused teams, they are going to want to build features, right? And the product owners are going to be pushing the feature roadmap because that's their job. And it's very easy for certain changes, like improving how the pipelines work or the machinery which underpins the development processes. It's very easy for that to get lost in favor of building the next great feature. So one of the things we're very strict on now is that the product owners only have 80% of the dev team capacity to play with. Right? They can do whatever they like in that 80%, but they cannot use more than that. 20% is reserved for continuous improvement, improving the pipelines, improving the technology, investing in the kind of preventative maintenance which wouldn't normally get done if you were just solely focused on the product features. So I think that's a really important DevOps lesson that we've learned to help continuously invest in the machine. And that investment makes the product stuff go faster. So given our focus on speed, you probably won't be surprised to hear that we are now doing everything as continuous delivery. What you may be surprised about is that has actually reduced our downtime by 30%. That's because each change is now a very small change, it's very well tested, and it's deployed with automation in blue-green or canary-style deployments, which mean that if it does go wrong, we can just flip a switch, and within a few seconds, it's back on the old version. So it's a sort of retrospective governance. Most of the time, most of the changes will not cause a performance regression, so get it out there, monitor it, and if it's a problem, you can fall it back. And then 99% of the time, you've saved a lot of effort. Okay, that brings us on to automation. So I could quite happily talk about deployment automation for many, many hours, but I will spare you. What I want to do is show you this slide, which is the continuum of deployment. I'll give you a second to take that in. Okay, so on the far left there, we have our ugly pets. Home pets are fine. Pets in the server room, not a good thing. So those would be, maybe Windows servers with static IPs or manually install things which you can't auto-recover. Cattle, EC2 instances, you can just rebuild them on whim. Baked, where you've got an AMI which is running the application as well, so it makes it easier to auto-scale, and it moves you to some of the goodness of mutable servers. Containers, you all know about containers, and then the sort of holy grail of serverless architecture and Lambda on the far right. Now, the issue which Trainline, and probably a number of you have, is that we can't get rid of the pets overnight. But we don't want to stop our developers innovating and making use of some of the new technologies. So we also don't want 15 different tool sets for 15 different purposes. So we looked at various options in the market. We had a few false starts, and in the end, we decided to write our own tool to solve the problem in a more unopinionated fashion. And we did, and it's called Environment Manager. So Environment Manager is a platform for managing continuous delivery into AWS. And it's very much unopinionated. It doesn't care if it's Windows or Linux, doesn't care if it's blue-green, doesn't care if it's canary, doesn't care if it's immutable, and it will have container and lambdas coming soon. There are three main bits of Environment Manager. The first is a self-service portal. So this is where developers can go and manage infrastructure operations themselves. They can create an environment, they can deploy a service to that environment, they can scale up and patch ASGs, they can do all kinds of things themselves. There is an API, which makes it easy to integrate those things into your pipeline and automation. And then there's a number of operational and governance features which just give visibility into what's going on. So you can see at a glance what versions of what applications are where. So for example, compare my test environment versions to staging and production and show me the differences. A few stats. We're managing about 1,300 servers with it. We've done 25,000 deployments since January. Most of those are continuous integration and deployment things in the test environments. Normally, I'm used to saying we do about 70 production releases a week, but I actually checked the stats just before I came out, and it's 150 last week, which is quite a change from once every 6 weeks. We have 40% fewer JIRA tickets, so our infrastructure guys are freed up to actually focus on some interesting, again, proactive work, as opposed to just responding and firefighting the tickets. And it's massively improved our visibility and productivity. I don't have a stat in terms of 30% dev effort anymore, but it's certainly a lot less than it was. Okay, so who here is using or knows about console? Okay, not bad. What I'll do, I'll just give you a very quick summary so you can understand. We're actually using console for deployment. So console is a service discovery and health checking platform. So you have a number of console servers, and they talk to each other and elect a leader. You install the console agent on your nodes, and then they form this lovely mesh network using the gossip protocol, and they maintain the state of what is deployed where. And you can then query that catalog using HTTP or DNS. Console also includes a key value store, which you can use for your own application data. It doesn't specify how you use it, but it's a strongly consistent data store that you can use in your applications. Now, what we're doing is we're storing the target state for deployment in the key value store. And then we have an agent running on the machines, excuse me, Matt, which basically looks at the current state, looks at the target state, and if there's a difference, it will download the package to install from S3 and install it for you. Does that make sense? So it's a sort of eventually consistent, highly concurrent deployment mechanism. And again, it's agnostic. If you want to have just one thing running on your server, that's fine. If you want to do multi-tenancy, which with Windows you often have to do just for cost efficiency, again, that's also fine. It works on Windows, it works on Linux, it's very unopinionated. It's very, very scalable. So you can actually define the target state for a whole environment and then start creating all the infrastructure, and it will all boot up, download and install and set itself up for you. So how does that work in practice? So we have our CI pipelines. We use TeamCity. They call a deployment API an Environment Manager. So that basically says deploy this service at that version to that environment, please. That's all it needs to know. An Environment Manager will upload the package to S3. It will update the target state in console, and then it will create the infrastructure in AWS for you. Or it will reuse it if it already exists. Matt, you might be needed here. Okay, so what that means is, so the instances have the deployment agent installed. They boot up, they read console to look at the current state and the target state. They then download any packages which are missing and install them on the boxes. Okay? And what this means is that Environment Manager creates the infrastructure for you. So as a developer, you don't need to know what the tagging standards are. You don't need to know what the naming standards are. You just have to say, deploy this thing, and it will take care of it. It'll be consistent in every environment it's deployed to, which is using the same map. And finally, the instances report status back to console, so we get a real-time view of how deployments are progressing across the environment as well. So it's highly scalable, cross-platform, multi-tenancy, concurrency safe. It's got auto-scaling support. How many of you have played with AWS Code Deploy, the service? Did you know there's a race condition? If you are deploying whilst you scale up, the new machines might still get the old version. That's not something which would happen in this model. And we also get real-time visibility into what's going on with the deployment. So let me show you some screenshots. So this is Environment Manager. We're looking at the services section. And basically, let's go for a scenario where we're just deploying a brand new service. So it's a brand new service. It's a bit washed out. There's a create new button. We just enter some basic information about the service, what it is, what it does, who owns it, that kind of thing. And it gets added to the service registry. That means you can't deploy anything which isn't in the service registry. So there's a gentle forcing function there to make sure that you always know what can be deployed. You then set up a deployment map. This is very washed out. But there are boxes here which represent each auto-scaling group. And you can specify which services get deployed to which auto-scaling group. And you can click on these to edit the settings. So for example, you can say who to email in the case of a problem with a server. You can set up the configuration, which AMI to use, which subnets, all these kind of things. And obviously, you can say which services you want to deploy onto that role. And then all you need to do is use our API to deploy that service. And our API looks like this. So if I drill into the deployment API, there's an endpoint where we basically say, what's the service, what's the version? This would be what you've called from your continuous integration pipeline. And then it would go ahead and deploy. And what you're looking at here is all the deployments which have happened. And you can click on one of the deployments and you get this nice view, which is basically a tail log of, as it goes through, what it's deploying and which instances. And you can see the full log of that machine. So you can actually jump and see the installation log from that server. And it's just one more thing I want to say about Environment Manager, which is that it is, as of today, open source. So if this sounds like something which is useful to you, please have a play. Let us know what you think. OK, so where were we today? We are basically 100% in AWS. Our dev, test, and production servers are all in AWS. We have 250 microservices instead of a monolith. We did 150 releases last week, which surprised me. We have 30% less downtime now we're migrated to AWS and using continuous delivery. It now takes us 2 hours to build an environment rather than 2 weeks. And we'll top it off, we've also made a £1.2 million saving on our infrastructure hosting every year. But we're not done. As I said, there's a load of stuff we want to do around big data and a lot of investment we're going to do there to try and help customers with their travel. So I'll leave you with this. Please download the app if you haven't already. You can follow us on Twitter. We have an engineering blog where there's an announcement about Environment Manager, and you can see all the summary of the information. And if you want to check out the code, there's a link again for the Environment Manager code base. And that's me. Any questions?
Well, actually, before we get on to the first question, thank you so much for that. I'm going to actually ask Matt to come along to give Chris a helping hand. I think you're doing a phenomenal job there. So, first question.
Hi.
Sorry, put your hand up.
Yeah, for the Environment Manager deploys, if they're coming from S3, do you have to standardize on a packaging format like RPM or Debian?
We actually use Amazon's code deploy zip format because it's very agnostic. It's basically just a zip with a metadata file and then whatever you want inside that.
So all the
Yeah.
They use a YAML file, right, with all the scripts and everything.
Exactly, yeah. So it can be a .NET project, it can be Python, it can be Node, it doesn't matter.
Can I ask you then why you didn't use code deploy for everything then? Is it just for that race condition?
It's not just the race condition, no. There's a number of problems with code deploy, not least the fact it doesn't support multi-tenancy. So if you imagine a Windows server uses like this much capacity, this much is Windows before you start. So you can't use the smallest instance types, and you can't, cost effectively single tenant each of those services. So on Windows, multi-tenancy is kind of essential from a cost point of view, and code deploy doesn't really support that.
Any other questions? No? Well, one more. Okay, hold on. Final question.
Hi. How did you deal with educating or training the multi-discipline teams to use the new platform and to adopt the new methodologies?
I can take that. Basically started with a headline group of early adopters, people who are interested in this to start with. People who are, there's always some development teams who are, we want to do stuff better, we want to change the way we do this. So effectively, some of this happened before I started Trainline, so correct me if I'm wrong.
Yeah.
But basically finding those early adopters, working with them, working in the small groups, the kind of two-pizza team type scenarios to flesh out the details of that. That's how we got to things like finding out that code deploy wasn't quite the right tool, and gradually innovating in that sort of way.
Yeah, and we also do induction training for all our new starters, so they get taken through the tool and how it works, and champions in different teams which can train.
You done?
Yeah.
How long did it take to develop this environment?
I hacked the first version together over Christmas, and then it evolved into a monster. So probably 6 months of proper development with a team.
You have a dedicated team who is continuously looking.
Yes. So our infrastructure guys provide platform services. So basically, we wrap Amazon and provide services to our dev teams. And Environment Manager is one way we do that. And inside the sort of infrastructure team, we have a development function as well. So they are responsible for building it.
And it's just the beginning as well, because it's just been open source today, and already we've got lots of interest from people who are wanting to use it for things like, what's that container technology? I don't know, container technologies. All sorts of extra things that we want to do to it. So yeah, it was a long time in the making, but hopefully it's the start of something that can be more community
useful. We
useful.
hope it's genuinely going to be useful to a number of companies. And yeah, as Matt says, it's very early days really in terms of, it does what we want, but there's going to be a lot of stuff which we're going to do to make it better over time.
One more thing. How are you convincing the teams? Because there will be a lot of teams under Trainline. So how are you convincing them that they should be using the environment manager? Because every team wants to do their own stuff and they want
Micro-optimization. Yeah. As a company, if you've got 15 dev teams, you do not want 15 different deployment tools, right? But each dev team will be convinced that their particular tool solves their problem in a way which nothing else could. The trick is to have a central tool, but make it flexible enough to work in a number of ways to support the different teams. And the way that it's forced is that you cannot deploy except via Environment Manager.
What language do you use to develop that?
It's an AngularJS front end, and it's a Node.js back end. And there are Lambda scripts, which do various housekeeping and things like that.
Well, thank you so much. Thanks for a great talk. Round of applause.